What if the purified water leaving wastewater treatment plants actually depends on billions of invisible organisms? Now, it might sound surprising, but the real workforce behind clean water isn't just pipes, pumps, and filtration systems, it's actually microbes, tiny bacteria, and other microorganisms that naturally break down waste. Inside wastewater treatment plants, massive microbial communities work around the clock to digest organic material and transform polluted water into something safe for the environment. Without this microbial cleanup crew, untreated wastewater would release large amounts of nutrients, harmful pathogens, and organic pollution into rivers and lakes. Excess nutrients can cause algal blooms that damage aquatic ecosystems, while pathogens can threaten drinking water supplies and public health. By harnessing the power of microbial communities to protect ecosystems, safeguard human health, and keep our water system functioning, in this video we'll explore how these microscopic organisms work together to turn waste into clean water. When most people think about wastewater treatment, they picture screens, tanks, and heavy machinery, but the process isn't just mechanical, it's biological. At its core, wastewater treatment depends on living, dynamic microbial ecosystems. As water moves through the treatment process, one stage stands out, the biological or secondary treatment phase. This is where microbes take over as the primary drivers of purification. Within these tanks, thousands of microbial species coexist, each performing a specific role. Some bacteria break down organic matter, things like food waste and human byproducts, into simpler compounds. Others specialize in nutrient cycling, converting nitrogen and phosphorus into forms that are less harmful to the environment. As described by Ioana Pasmanica and Janina Gospodarek in a 2022 article titled Assessment of the Impact of Selected Industrial Wastewater on the Nitrification Process in Short-Term Tests, one of the most important ways microbes help purify water is through a process called nitrification. When wastewater enters a treatment plant, it often contains ammonia, or a form of nitrogen that can be toxic to aquatic life at high concentrations. Specialized bacteria step in first, converting ammonia into nitrite. This is done by microbes like Nitrosomonas, which use ammonia as an energy source. Then another group of bacteria, such as Nitrobacter, takes over, converting nitrite into nitrate, a more stable and less toxic form of nitrogen. This two-step process is essential because it transforms harmful nitrogen compounds into forms that can be safely removed or reused in the environment. By carrying out nitrification, microbial communities play a critical role in protecting water quality, ensuring that what leaves the treatment plant is far safer for ecosystems and human health. According to research by Taegeyu Kim, Sebastian Behrens, and Timothy Lapara in a 2021 article titled Direct Evidence for Deterministic Assembly of Bacterial Communities in Full-Scale Municipal Wastewater Treatment Facilities, it was shown that the most effective wastewater treatment systems don't rely on just a few types of microbes, they depend on stable, diverse communities. A stable microbial community keeps treatment performance consistent, even when conditions change. But when that balance is disrupted by things like temperature shifts, toxins, or sudden increase in waste, the system can become less efficient, leading to drops in water quality. Not all microbes need oxygen to do their job either. In fact, some of the most important work happens in oxygen-free environments. In these sealed tanks, called anaerobic digesters, specialized microbes break down organic waste without oxygen. As they do this, they produce biogas, mainly methane, which can actually be captured and used as an energy source. Scientists are beginning to discover even more ways to harness microbial power. In some innovative systems, certain bacteria can actually generate things like electricity while treating the wastewater itself. These are often referred to as electroactive bacteria. As they break down organic material, they release electrons. Instead of those electrons being lost, however, they're captured by different mechanisms, creating a small but measurable electric current. It's a promising approach, cleaning water while producing energy at the same time. As we've seen, successful wastewater treatment isn't just about pipes, tanks, and technology, it's about managing living microbial ecosystems. The infrastructure provides the environment, but it's the microbes that do all of the essential work. From breaking down organic waste to cycling nutrients to even generating energy, these microbial communities drive every step of the process. When they're stable, diverse, and well managed, treatment systems become more efficient, resilient, and sustainable. Without them, water treatment would be far less effective, putting ecosystems, drinking water, and public health at risk. In the end, protecting water quality depends not just on engineering, but on understanding and supporting the microscopic life that makes it all possible. billions of invisible organisms working together so that clean water can flow.